if f of x is equal to 3 times x squared minus x cubed, find the first derivative, the second derivative, the third derivative, and the fourth derivative. So let's find the first derivative. So let's take a look at the definition. So we know f prime of x is going to equal the limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay, so let's go ahead and evaluate. So using the function, we know that the input of x plus h is going to be 3 times x plus h squared minus x plus h cubed minus the function f of x, which is 3x squared minus x cubed, and then we're going to divide that by h. So now we need to square this binomial and we need to square that trinomial. So we have the limit as h approaches 0, and that's 3 times x plus h squared. If we FOILed that, we would get x squared plus 2xh plus h squared. And since we know that x plus h squared gives us this result, x squared plus 2xh plus h squared. Now we want to multiply it by another x plus h. So if we did that using the box method, whichever method that you want to use, the binomial theorem, so we're going to go ahead and multiply that all out. So we have x cubed 2x squared h, xh squared, x squared h, 2xh squared, and that's h cubed. Sorry, that should be x cubed here. So we have x cubed, combine those, which is plus 3x squared h plus 3x h squared plus h cubed. So that means we're going to have minus over here, x cubed plus 3x squared h plus 3x h squared plus h cubed, and then minus 3x squared minus x cubed, and then we're going to divide that by h. Now let's go ahead and distribute, and then we're going to combine like terms. So in the numerator, we're going to distribute the 3, and we get 3x squared plus 6xh plus 3h squared minus x, and distribute the minus to all 4 of those terms. So we get minus x cubed minus 3x squared h minus 3xh squared minus h cubed. And let's distribute that minus sign, which is minus 3x squared plus x cubed, and then divide that entire thing by h. So what can we combine to make 0? We have positive 3x squared minus 3x squared. We have minus x cubed, and we have positive x cubed. And then is there anything else that we can simplify? Doesn't look like we have anything else. So let's go ahead and now write down the rest of the function here. So we have 6xh plus 3h squared minus 3x squared h minus 3xh squared minus h cubed over h. And so now we can factor out an h in the numerator. So factoring out h, we're left with 6x plus 3h minus 3x squared minus 3xh minus h squared. Divide that by h. And so now what we can do is we can simplify that h. And now we want to take the limit as h approaches 0 of the function 6x plus 3h minus 3x squared minus 3xh minus h squared. And so now we're going to evaluate that at 0. So we have 6x, h is 0, 3 times 0, minus 3x squared, minus 3x times 0, minus 0 squared. So those all go away, and we get 6x minus 3x squared. And so therefore we would say that the first derivative of this function is going to equal 6x minus 3x squared. Okay, now let's find the second derivative. So if we want to find the second derivative, we're going to use the following definition. So we have the limit as h approaches 0 of the first derivative of x plus h minus the first derivative function over h. Okay, now let's go ahead and evaluate this. So the limit as h approaches 0, so we have 6 times x plus h minus 3 times x plus h squared minus the function 6x minus 3x squared divided by h. So now we have the limit as h approaches 0. So if we distribute the 6, we have 6x plus 6h minus 3 times x squared plus 2xh plus h squared. And then distributing this sign gives us minus 6x plus 3x squared all over h. Now let's go ahead and distribute the negative 3 to all three of those terms. So we have the limit as h approaches 0 of 6x plus 6h minus 3x squared minus 6xh minus 3h squared minus 6x plus 3x squared over h. And so now in the numerator, can we combine like terms and then simplify anything that adds to 0? So we have 6x minus 6x minus 3x squared plus 3x squared. So now we have the limit as h approaches 0 of 6h minus 6xh minus 3h squared divided by h. And so now we can factor out the h in the numerator. So if we factor out the h, we have 6 minus 6x minus 3h divided by h. We can simplify the h's. So we have the limit as h approaches 0 of 6 minus 6x minus 3h. And so if we apply the 0, we have 6 minus 6x minus 3 times 0, which gives us 6 minus 6x. And therefore we would say that the second derivative of this function is equal to 6 minus 6x. Okay, now let's find the third derivative using that function. So if we find a third derivative, the third derivative definition states that the limit as h approaches 0 of the second derivative of x plus h minus the second derivative function over h. So going back down here, we know that the second derivative is 6 minus 6x. So we're going to find the limit as h approaches 0 of 6 minus 6 times x plus h minus the function 6 minus 6x, and then we're going to divide that by h. Okay, so now let's distribute this negative 6 to both of those terms and this negative sign to those terms. So we end up getting 6 minus 6x minus 6h minus 6 plus 6x divided by h. So 6 minus 6 gives us 0. Negative 6x and plus 6x gives us 0. So we get the limit as h approaches 0 of negative 6h divided by h, and therefore that h becomes 1. So the limit as h approaches 0 of negative 6 is going to equal negative 6. And therefore we would say that the third derivative is equal to negative 6. Okay, so now we want to find the fourth derivative. Okay, so the definition of the fourth derivative is equal to the limit as h approaches 0 of the third derivative of x plus h minus the third derivative function all over h. So that means we want to find the limit as h approaches 0. Well, the input of x plus h, it's a constant, so we know it's just going to be negative 6. And then it's going to be minus the third derivative, which is negative 6. And then we're going to divide that by h. So the limit as h approaches 0 becomes negative 6 plus 6 over h. Negative 6 plus 6 is 0 over h, which means this becomes the limit as h approaches 0 of 0, and that means that 0 is a constant. So we would say that the fourth derivative of this function is going to equal 0. Okay, so now what we want to do is we want to graph all these functions on one graph. So stating here, it says you want to graph the function, the first derivative, the second derivative, and the third derivative, and the fourth derivative on this function. So let's go ahead and do that. So the first function is 3x squared minus x cubed. That is the function, and then the derivative is, the first derivative is 6x minus 3x squared. And then the second derivative is 6 minus 6x. The third derivative is y equals the value of negative 6, which is the constant. And then the fourth derivative is 0, so that's y equals 0. So let's go ahead and take a look at this graph. And let's talk about this graph. Okay, you can see here the graphs are consistent with the geometric interpretations of the derivative because the first derivative, okay, so what I mean by that is the first derivative was 3x squared minus x cubed, which is the one in red. Okay, so if we take a look at their horizontal tangents, there's one at 0 and then there's another one. So then that gives you those x-intercepts. The second derivative is 6 minus 3x squared, which is the one in blue. And so therefore we have a horizontal tangent there, which then has an x-intercept here. And then if we take a look at the third derivative in green, we have 6 minus x squared. So there we have 6 minus x squared, which is a linear function. And therefore there is our third derivative, which is a constant function, which is the one down here. So the graphs are consistent with the geometric interpretations of the derivative because, again, f prime has zeros, where f has a local maximum. A local minimum and a local maximum. So this is a minimum, this is a maximum. And then the second derivative has a 0 where f has a local maximum. And then the constant, the third derivative is a constant function, which is equal to the slope of the second derivative.